Hello. So here's another exercise. A circular observation window on a marine science ship has a radius of 1 foot and the center of the window is 8 feet below water level. As shown in figure 7.72, I'll show that figure to you later. What is the fluid force on the window? So we have a round window, okay, a circular window of radius, I'm gonna drag it out here. Radius 1. So the radius here is 1. Okay, and it's 8 feet. The center of the window is 8 feet below water level. So you have the water here, right? And the distance over here is going to be 8 feet. Let me just grab from here, there. This is going to be 8 feet. We're just working with feet, so I'm not going to put the FT here. Okay, and it wants to know the force in here of the water. Okay, so we're going to do the same thing. We have to find the value of X. So you have this area here, and you have a pressure here which is large, another pressure here which is a little bit lighter and lighter and lighter and lighter. Okay, now first of all, you need a Cartesian plane in here. You need a coordinate system, two-dimensional coordinate system. You could put like this point right here to be the 0, 0, but we're not going to do that because you want to relate X with Y, and you don't want to be like X squared plus Y minus 8 squared equals 1 squared. No, because you see, guys, I don't know if you noticed this. I don't know if you know about this, but for example, if you have a circle, the equation that relates the circle X and Y is X, okay, X minus X, I'm going to put XC, which is the center of X, the X coordinate for the center, squared, plus Y minus YC squared equals the radius squared. All right, now if I make this point right here becomes the 0, 0, then I can just cancel these two. It's going to be X squared plus Y squared is equal to 1 squared because the radius is 1. Okay, so that's what I'm going to do. All right, so I'm going to say that the point 0, 0 is over here. So we have, let's see, the force is going to be the weight density, and the weight density is being considered 62, okay, not 62.4, or hold on, 64, not 64.2, 64 times the integral from, now here we go, because the point 0, 0 is here, you want to go from y minus 1 to y1, minus 1 to 1. Alright, so you already have the weight density and you have the L. Now what is going to be the L? Well, the L is going to be twice the value of X. Now let's relate X with Y. You have X squared plus Y squared equals 1. That means that X equals the square root of 1 minus Y squared. Okay, you don't have to worry about the minus here because we're just going to be concerned with this positive part of the X. With this positive part of X, and we're going to multiply by 2 to get this one. Okay, so twice X is going to be twice this thing. What is this? This is the Ly of the function. Okay, so it'll be 2 square root of 1 minus Y squared. Okay, and then you have the depth. Now, when X is 0, when Y is 0, this depth right here, what's going to be the depth? 8. When Y is 1, what's going to be the depth? Well, it's going to be 8 minus 1. Okay, so you can see by inspection that the depth is going to, which is the HY of the function, the depth is going to be, hold on, it'll be 8 minus y, and that's it, and then I have a dy. Okay, now y, because for example over here the y is equal to 1, so what is the depth? Well, from here to here is just going to be 7, right? 8 minus 1. When y is over here, which is minus 1, then you have 8 minus 1, the depth is 9, and the depth is 9. Okay, so there you go. This 2, I'm going to get it out. I'm going to make 128. So I'm going to get this thing out of here. I'm going to drag this a little to the right. I'm going to erase this and put 128. And now it's a little bit complicated. That's why we studied transcendental functions before, okay? Because you see, you're going to have to break this into 2 integrals, all right? So this thing here, okay, it's already set up, so I'm going to erase all this stuff. Okay, and I'm going to drag it up. So this is going to be equal to 128 is multiplying everything, so it'll be 128 the integral, and then you see I'm going to do 8 times this stuff minus y times this stuff. So it'll be 128 times the integral of 8 times this. Well, 8 is just a, how can I say, 8 is just a constant, so I'm going to take it out of the integral. So 128 times 8, right? 6, 16, and 6, 22, 8 and 2, 10, right? Yeah, there's another way of looking at this. This is 2 to the 7th times 2 to the 3rd, which is 2 to the 10th, which is 1024. So 1024 times the integral from minus 1 to 1 of the square root of 1 minus y squared, okay, dy, plus, and now it's going to be 128 times, well, it'll be a minus y, so I'm just going to put it over here, okay. The integral from minus 1 to 1. So this minus, I already put it over here, it'll be y. Square root of 1 minus y squared dy. Okay. Now, here are a few ways that you can look at this stuff. Okay. For example, this one over here, that's why we use transcendental functions. This is in the form integral of the square root of a squared minus u squared, but u is actually y, so I'm just going to put the y squared here, where a is equal to 1, okay? So this was equal a squared times the arc sine of y divided by a plus y square root of a squared minus y squared. All right? So let's think about this. The a is just going to be 1. So forget about this. 1 squared is just 1. Okay? Forget about this here because it's just 1. This thing here is going to be 1. So let me erase this slowly. There. That's what you have. Okay? From minus 1 to 1. The integral is going to be equal to that. And here, I'm just going to put a 1. Okay. Okay. Now, this is one way of looking at it, and you can solve it this way by plugging in the 1 here and then plugging minus 1. For example, what's the arc sine of 1? Well, the sine is going to be 1 when it's pi divided by 2. Okay, so this thing here is an angle. This is going to be pi divided by 2, and then you're going to go like, when it's time to do the minus this, it'll be minus the arc sine of minus 1. The arc sine of minus 1 is minus pi divided by 2, so it's going to be pi divided by 2 again, right? And here you're going to have a 1 times this minus 1 times this. But you see, the problem is, here if you plug in a 1 here, you're going to get a 0. If you plug a minus 1 in here, you're going to get a 0. So you don't have to worry about that. So it's just going to be 2 pi divided by 2, right? It's just going to be pi times 1024. Yeah. 6, 3, yeah, it is. Let me just think here, guys. Just thinking about one thing here. For some reason, I think that I made a mistake with this 1024 here. But it's 8 times this, okay, minus the y times this, and 8 times this stuff is 1024. Oh yes, because you're going to integrate. Yeah, right. Never mind. Okay, so when you do that, it'll work like this. Okay, fine. So, oh yeah, this is being multiplied by 1024, right? So you have 1024 here, and you have 1024 here. That means you have, when you take this out, yes, it'll be pi divided by 2, or, well, yeah, you can factor out either way you want, right? Yeah, 5, 12, yeah, that's strange. Anyway, you can do it like, oh, hold on, what the heck am I doing? Okay, you can do it like this, okay, by solving for this. Now, another way that you can think about this is like that. You have a circle. I'm going to make a crazy circle here, okay, a radius 1. And then, what is this stuff right here? This stuff is the value of x, okay? Oh, okay. All right, never mind. So this stuff right here is going to be the value of x. Remember, x squared plus y squared equals 1. That means that x equals square root of 1 minus y squared. Okay, so this is the value of x for every y. So if I give you y here, it's going to get this value of x. If I give you y here, it'll give you this value of x. If I give you y here, it'll give you this value of x. Okay, so you can see that this integrating from top down here all the way to the top is going to be this half. Okay, all you got to do, so this right here is actually, this thing represents the half of this area. Now, what is this area? It's pi r squared. R is 1, so it's just going to be pi. Divided by 2 is pi divided by 2. So you can see that this thing here represents, I'm going to erase this stuff. This thing here represents 1024. Yeah, I'm right. I was not wrong, guys. I was right. Times pi divided by 2. Okay? That's what it represents. Pi divided by 2 is the area, is half the area, represented by this, and then you have to multiply by 1024. This thing right here, it's going to become a 0. Why? Because if you plug in a 1 here, it'll be 1 minus 1 squared, that's 0. If you plug in a minus 1 squared is 1, 1 minus 1 is 0. So this thing is just going to go away. There's something else too. If you take this function, you can see that f of minus y equals minus f of y. Let's see. Plug in the minus y in there. You have minus y square root of 1 minus y squared. Because if you plug in the minus y in here and you square it, it'll become positive, right? Equals minus the f of y. So I'm just going to copy this thing here. It'll be y square root of 1 minus y squared. Okay, so you can see that this equals this, this equals this. That means that it's an odd function. And an odd function, which is symmetric about the origin, okay? When you have limits of integration that are symmetric positively, from negatively to positive, or from the negative part to the positive part, like -4 to 4, minus square root of 7 to square root of 7. Over here, -1 to 1. The negative part cancels the positive part. Okay, so if you have a function like this that's perfectly symmetric, I don't know, let's do it, I don't know, man, like this, symmetric about the origin, so it goes like that, this one goes like that, okay? So when you integrate this thing, for example, from this part, which is, let's say, -3, to this part right here, which is 3, you're going to have this area, and this area is going to be canceled by this negative area here. That's one thing of odd functions, okay? Even functions don't do that, but odd functions do. So if you integrate from -3 to 3, you're just going to get a 0. It's the same stuff in here. You integrate from -1 to 1, from -2 to 2, from -103 to 103. This is going to be 0, so don't worry about that. So in the end, you have equals 512 pi. That's going to be the force, okay? And that's it. I know it's confusing, it's crazy, it's too much information, and I like to be messy, but hey, it works. I'm going to show you the situation here because it's easier when you can visualize. The situation is this, okay? Hold on, I have to put this up here a little bit more. There you go. See, the height's 8 minus y. Here's the water, and here's going to be the point 0, 0, and there you go. You're dividing the surface of this round circular observatory, whatever you want to call this thing, submarine window. You're dividing it into infinitely thin horizontal bars, okay? These slits, and you gotta calculate the force in this slit plus the force in this slit plus the force in this slit, and the force is just gonna go higher and higher. It's just gonna increase more and more as you go down because the pressure is increasing too. So there you go. That's it, guys. The final answer is 512 pi. 512 pi watt of force. Okay, this is gonna be lbs, pounds. That's it.